Welcome everybody. So let's have a look at this numerical portion. As we have discussed earlier, the length of transition curve can be calculated by different methods. One is the rate of change of centrifugal force. Next is the introduction uh, as the introduction of super elevation is provided. According to that, we can also calculate. Next method is as per the IRC recommendation, right? So we'll use all those methods to calculate the length of transition curve. So in this case, the length of transition curve, the numerical has been given. The national highway is passing through the rolling terrain in heavy rain. Horizontal curve of radius 500 meters is designed on the highway. Then the length of transition curve for that. So for heavy rain, we can say that camber is equal to 2%. The radius of curve is given as 500 meter, and length of transition curve we have to calculate, right? Next, design speed is equal to 80 km per hour. It is because the transition curve is designed on national highway. That is why the design speed is taken as 80 km per hour, right? Next, to calculate the length of transition curve, we'll use this formula. For this formula, C is given as 80 upon 75 plus B. So we'll input the values of B and we'll calculate the value of C. 75 plus 80. Let me calculate the values. 80 plus 75 multiplied. The value is equal to 0.516. Since the value has to be greater than 0.5 or 0 or less than 0.8, you already know that the value of C must lie between 0.8 and it should be greater than 0.5. If the value is such that it is between these values, C is taken as it is, so C is equal to 0.516 is the value for this case, right? So what else do we need here? We do not need anything else. This is 3. So we have to 0.215 multiplied by 80 cube divided by 500 multiplied by 0.516. The value will be coming out to be 80 power 3 multiplied by 0.215 is divided by 500 is divided by 0.516. The value is coming out to be 426, which is wrong. We'll have to calculate again. 80 cube multiplied by 0.215 to 500 is to multiply by 0.516. The value is coming out to be 42.16. We'll have to calculate this value again. Let's have a look what is the value. What is the formula for that? Rate of change of centrifugal force. The formula is this. This we are not including. It is formula is wrong. It is actually converted to be wrong. We have to include 0.0 and 0.0. Now let's get the value. 80 multiplied by 80 into 0215 is 500.56. The value has to be divided by 80 cube 0.0215 divided by 500 divided by 0.516. The value is coming to be, now it is correct. It should be approximately in the range of 40 to 150, and the value that is whatever value we are getting maximum should always be used. So this is the first case where we are calculating by rate of change of centrifugal force. Next we will use the Formula for change of super elevation criteria. Second is the rate of change of super elevation. So for this, the formula is same as provided earlier, which is equal to Ls equal to Nx. It can be E and W plus W, or it could be E upon E W plus W, depending upon the rotation is done upon inner edge, or it is done along the center line of the road. So for this case, we'll assume it to be done along the, we'll calculate for both the conditions, and then we'll find the maximum value. So what was the formula? Ls is equal to N E upon 2 W. So W is equal to W plus W. So here E is not available, we'll have to calculate E as well. So for calculating E, super elevation has to be designed, which is equal to E plus F is equal to design super elevation, right? E plus F is equal to E square upon 127 R. F is to be taken as 0 and E is equal to B square upon 225 R. If the value is designed for 75% of the traffic, since the design of the elevation has to be done for 75% of the traffic. So this formula will be used, and B is equal to 80 square upon 225 multiplied by 500. So E is equal to 0.5689. This would be in percentage, right? And since the value is less than 7%, hence the value is okay. It is not in percent, it is in points itself, right? So E value would be equal to 0.05. According to this, we'll calculate the value of transition curve. For radius when greater than 300 meters, the extra widening is equal to 0, and W plus W will be reduced to W only. So length of transition curve will be equal to N E upon 2 W, where N is equal to 1 in 150. We'll assume the, as given in the question, the terrain is rolling terrain, right? So for rolling terrain, N is equal to 1 in 150, right? So length of transition curve is equal to 1 upon 150 is equal to 150 upon 2 multiplied by 0.056, which is multiplied by W. The width of the road is 7 meters. Nothing is given in the question. Next line, we're passing a horizontal curve, the radius is design, and the design length of transition curve. Okay. So no width is given for 7 meter. We'll write, assume 2 lane carriage way. So W is equal to 7 meter, right? So we'll calculate the value of transition curve, 75 The value is 75 multiplied by 0.056 is multiplied by 7. That comes out to be 29.4 meters. Next, we'll calculate for IRC. Third is for as per IRC recommendation. As per the IRC recommendation, the formula for rolling terrain is length of transition curve is 2.7 v square upon r, where v is in kilometer per hour and r is in meter. Since this is a empirical formula, there is no restriction on the type of values that we use for the values that the units that we have to use for the formula is as per the given empirical formula, right? So this would be 2.7 into 50 square upon 500. Value will be to 34.56 meter. Since length of the transition curve, it is equal to the maximum of three values. So for three values, the maximum value is, first value is this, that you have to have a look. Next, the value is this. We'll have to have a look at this also, and the length of transition curve provided by change of centrifugal forces for 2.6. The value of transition curve hence would be, it would be equal to 42.6 meters. So that is all for this numerical. Have a good day. Sorry the videos were very late, and I'm sorry I was busy in some classes. So that's all. Kindly like, comment and subscribe. Have a good day.